Topic number 4, we have the shearing deformation. Shearing forces cause shearing deformation. An element subject to shear does not change in length but undergoes a change in shape. If you remember, under the topic of the axial deformation, so under the axial deformation, you have your change in length if the body is subjected to tension, therefore it elongates, and if it is under compressive forces, then the body shortens. So in here, hindi siya nag-change ng length, but it changes the shape. So imagine this as a box of jelly and you are on the other side, and then ang gagawin natin is to apply a shearing force. So of course, the shearing force is parallel to the surface. So if you apply the shearing force, yung box of jelly natin ay tutumba, and the change in angle at the corner of an original rectangular element is called the shear strain. And here, this is the shear strain, and this portion here is the displacement, and this is the original length. So we have here the shear strain is equal to the deformation over the original length. Correlate natin siya dun sa strain natin sa axial deformation, and that is just equal to the change in length over the original length. The ratio of the shear stress and the shear strain is called the modulus of elasticity in shear, or tinatawag nating modulus of rigidity, and it is denoted as G. So if we are going to relate this from the definition, so the modulus of elasticity is equal to the axial stress over the strain. So from the definition, the modulus of elasticity is stress over strain. So here, in shearing deformation, the modulus of rigidity is stress over strain. That stress is shear stress, and that is shear strain. So the relationship between the shearing deformation and the applied force is the deformation here is VL over ASG. So V is the shear force, L is the length, AS is the shear area, and G is the modulus of rigidity. Since we know that the shear stress is force over the shear area, therefore itong V over AS ay pwede na natin palitan ng shear stress. So therefore we have this another formula, and if we are going to relate this in the axial deformation, so we have the deformation is equal to PL over AE, and this is also equal to stress L over E. Mukhang magkamukha yung equation nila. As you can see, we have here the shearing deformation and the axial deformation, and we have here the shear force. So ang katumbas niyan dito sa axial deformation is the axial force P, and the length the same. The area here is parallel to the force applied, while the area here is perpendicular to the force applied. And we have here the modulus of elasticity in shear, denoted as G, or the modulus of rigidity, and ang counterpart niyan dito is the Young's modulus of elasticity. And for another formula, we have shear stress here, axial stress here, and we have the L, and denominator G, the modulus of rigidity, and the counterpart of that in the axial deformation is the modulus of elasticity. And later ay i-relate natin yung formula na to kasi kamukha din to ng formula dun sa topic natin sa torsion. What is Poisson's ratio? When a bar is subjected to tensile loading, there is an increase in length of the bar in the direction of the applied load, but there is also a decrease in the lateral dimension perpendicular to the load. Itong unang statement, sinasabi lang nito na kapag yung isang body ay in-applyan natin ng tensile force, the tendency is this body would change in length. So we have here the deformation, and if this is the original length. But this would result to the decrease in a lateral dimension perpendicular to the load. So meaning, so ito yung mangyayari sa kanya, no? So magkakaroon siya ng decrease sa dimension na to. And ang kabaliktaran nito, if we apply a compressive force sa isang body, so that would shorten the body. Kung i-consider natin yung cylinder and we apply a perpendicular load P, so what will happen is this body will shorten and the diameter would increase. So pasimplihin natin yung mga bagay-bagay. Pag inunat, so hahaba pero liliit. And kapag kinompress, siya ay iiksi pero lalaki. So the ratio of the sideways deformation or strain to the longitudinal deformation strain is called the Poisson's ratio, and it is denoted as V. So for most steel, it lies from 0.25 to 0.3 and 0.2 naman para sa concrete. So in here, ito na yung sinasabi ko kanina, if we apply force P, no, so what will happen is hahaba siya pero liliit, no? So with respect to the y-axis, and we have here the Poisson's ratio is the negative of the ratio between the strain in y with respect to strain in x, and it is also equal to the negative strain in the z-axis over the strain in x. So EX here is the strain in the x direction, the y and the z are the strains in the perpendicular directions. The negative sign indicates a decrease in the transverse dimension when the strain in x is positive. What is biaxial deformation? If an element is subjected simultaneously by tensile stresses, the sigma x and the sigma y, in the x and y directions, the strain in the x direction is sigma x over E, and the strain in the y direction is sigma y over E. Simultaneously, the stress in the y direction will produce a lateral contraction on the direction of the amount negative of the product of the Poisson's ratio and the strain in y, or negative of the Poisson's ratio and the product ratio between the stress in y and the modulus of elasticity. So, para madali nating matandaan yung formula na to, what we are going to do is, since itong formula na to at ang formula na to ay magkamukha, no? So, pareho silang stress over E, and we have the Poisson's ratio, stress over E. So, nagkakaiba lang sila dun sa may subscript. So, for the strain in X here, since sa biaxial deformation na pinag-uusapan natin dito, dalawang axis lang, si X and the Y axis. So, for the strain in X, dito, stress in X. And, of course, kung X yun, since ang kabilang axis is Y, so therefore, Y naman yung nandito sa part na to. And if this is Y, so we have here the stress in Y here, and of course, dito, yung kabilang axis, which is the stress in X. So, if we are going to express this in terms of the stress, so we have here the stress in X is equal to this formula. So, kung titingnan natin dito, magkamukha ulit yung formula na to. Of course, ang pinagkaiba niya lang, subscript pa din. We have here the stress is equal to the strain plus the Poisson's ratio and the strain and the modulus of elasticity over 1 minus the Poisson's ratio square. So, if this is X, this is X, this is Y. The subscript here is Y, this is Y, and this is X. So, para magkaroon ka ng formula na to. How about in the triaxial deformation? So, sa triaxial deformation, magkakamukha din yung formula nito. And you have here the sigma minus the V, the sigma, and the sigma. So, kung i-relate natin ito doon sa may biaxial deformation, it looks like this. Since we know in the biaxial deformation, so we have the strain in X is equal to, so we have here the sigma X over E minus the Poisson's ratio sigma of the other axis over E, wherein ito yung formula natin kanina sa biaxial deformation. So, pinagbalya lang dito sa triaxial deformation is that nadagdagan ka ng isang axis. So, dito sa part na to, wala namang nagbago kasi that is the sigma X over E minus the Poisson's ratio. So, dito, nadagdagan ka ng isang axis. So, you have the Y and the Z here, of course, over E din to. And if you factor out the modulus of elasticity, and you would have this formula. So, kaya lalabas yung formula na to. Now, for the strain in Y, mauuna dito si Y. And since Y to, ibig sabihin X at saka Z yun nandun. And if this is Z, so Z yun nandito, the other two axes, that is the X and the Y. So, kahit mag-memorize ka lang dito ng isa, alam mo na rin itong dalawang to. Tensile stresses and elongation are taken as positive. So, if the body undergone tensile stress, therefore, magkakaroon siya ng elongation, and that elongation is considered as positive. But if the body is under compression, then magkakaroon ng contraction, so it is taken as negative. So, what is the relationship between the modulus of elasticity, the modulus of rigidity, and the Poisson's ratio? So, we have this formula here. G is equal to E over 2, 1 plus the Poisson's ratio. So, nagagamit natin itong formula na to if isa sa kanila nawawala. Halimbawa, binigyan ka ng Poisson's ratio, binigyan ka ng modulus of elasticity, then you can compute for the value of the modulus of rigidity. And of course, kung given is the modulus of rigidity and the modulus of elasticity of the material, then you will be able to compute for the Poisson's ratio. And of course, kung ano naman yung modulus of elasticity, then given naman yung modulus of rigidity and the Poisson's ratio, then you will be able to compute for the modulus of elasticity. Topic 9, we have here the bulk modulus of elasticity or the modulus of volume expansion. So, kung kanina pinag-uusapan natin is the shear. So, yung unang napag-usapan natin is the modulus of elasticity. Then, lately, we have the modulus of rigidity. Now, here, in the volume expansion naman, we have the K, which is the bulk modulus of elasticity. Now, so this is the measure of the resistance of the material to change in volume without the change in shape or form. So, nag-change yung volume niya, pero yung shape and form niya ay hindi nagbabago. And we have this formula here, E over 3 times 1 minus 2V. And from the idea that this modulus of elasticity here is stress over strain, and this modulus of rigidity here is also stress over strain. Therefore, this K here, which is the bulk modulus of elasticity, is stress over the strain, wherein this strain here is the ratio between the change in volume and the original volume. Now, the ratio of the change in volume over the original volume is called the volumetric strain. Ang strain natin dito, we have the axial strain. Ito ay shear strain. We have the volumetric strain. Now, if we are going to express the volumetric strain in terms of the stress and the bulk modulus of elasticity, therefore we just equate this equation and this K here and we would have this. So, iaakit lang naman natin, magpapalit lang naman ng position si K at saka si volumetric strain. So, therefore, we have here the sigma over K. Kung itong dalawa naman yung i-equate natin, so, ang denominator na to ay mapupunta dun sa numerator, and of course, you have here your stress, and this numerator here ay nandito na siya, and itong volumetric strain natin will be on the other side of the equation. So, we have here the formulas for the volumetric strain.